My name's Dan Woods. I am the principal analyst at Early Adopter Research and also the CEO and founder of Evolve Media. Early Adopter Research is an analyst firm that tries to find technology for early adopters, and Evolve Media is a content marketing firm that helps vendors tell their stories. I recently had a great time attending 5 cities in the Neo4j GraphTour. My talk was on how to find the $100 million graph query. And it was a really fun talk because I made it better each time, and I talked to a lot of Neo4j customers each time. And what it came down to is that if you really are going to systematically adopt graphs, you have to do a bunch of things. And I went through the kind of typical, enterprise maturity model where you first find initial use cases, and then you gradually create a center of excellence, and then gradually expand that, and then make it operationally secure, and then do the super advanced stuff and put it in operations. And you have to think about all those things at once. And that's pretty much the story with any technology. How do you make it go from the experiment and the skunk works all the way to production? I found that there were 2 things that people really struggled with that really were the key to systematic graph adoption. One was, how do you make a large number of people understand the power of thinking in graphs? And what I mean by that is, how do you understand what questions you can ask with a graph query, a graph algorithm, and graph analytics? If you can get a lot of people to understand now, I can ask these questions with Cypher, I can do these algorithms and now understand or process the data differently. I can use analytics to look at the whole corpus of a graph and tell me things about it. Now all of a sudden they're going to think, and when they see data, they're going to go, wow, if I had a graph, I could answer this question. That would be really cool. That then creates demand for actually creating the graphs, and then that then finds your way to really powerful applications, because the kernel of the idea started with the person in the business. So that's the first thing. How do you get as many people as possible competent to think in graphs? The second thing is, once you have those ideas bubbling up, then you have to build the graphs. So the problem there is that building graphs is great. There's lots of examples of, I can take this relational table and put it in a graph, and it's all trivial. But when you start doing something that has 5 or 6 sources of information, or 10 or 20 sources of information, what happens is you have this graph ETL problem. Now, with a regular relational ETL, you take a source of data, you maybe massage it so it looks like tabular form, and you just dump it into the RDBMS structure, and then you're done. And then all the complexity of knitting that together happens in the SQL query. With a graph, it's a lot different. You take the data, you collect it, and now you either dump it into a node or a connection property, and it's not a table, it's the properties of a node. That's the idea of a property graph. Or it's a connection between 2 nodes that has properties. So let's say you dump a bunch of nodes in. Now you have to have a program that understands how to connect those nodes and how to assign the properties to the connections. Okay, great. But that's no longer just dumping in and then having the complexity come later in the query. That's a complicated program. And then, of course, you have to understand when you're updating data and when you're not doing it. And so the graph ETL is the skill, I think, that's going to really be the boundary for companies as they try to adopt graphs. And I think that a lot of the cool things that Neo's doing with Morpheus are going to make that easier, by being able to reach out to relational tables, bring them in, and then have a systematic way of connecting them to a graph, and then updating it, and then taking and building that graph, and then putting that graph into Neo. But then having a way to go back and do that round trip again. That's, I think, going to be very powerful. It's not going to solve every problem, but it will make easier a few problems. And I've seen this over and over, like when I talk to people in cybersecurity, which is huge in graphs everywhere. How do they create these huge production graphs? It turns out that most of the time they spent was on the graph ETL layer, because that's the hardest problem. So that was what I learned on the GraphTour, and it was really interesting to have these ideas, but then also find people who are struggling with them. And so I think that it's at this point, though, and especially based on Emil's keynote, I think people are now going from just adopting graphs as a project-based thing to adopting graphs as a platform for their technology. And I think that that's the next challenge is how do you systematically adopt graphs? I also have been finding out how it's really interesting what's going on with Google Kubernetes Enterprise and Neo4j. There's some really interesting stuff where, once you get into the Google Kubernetes Enterprise world, all of a sudden you're in this world in which you have the ability to put code in these containers. And then the containers then are very easily scaled and the environment's very easily managed. You can also then reach out to the Google Cloud Platform Marketplace and find packaged things like Neo4j and pull them very easily into the Google Kubernetes for the enterprise system. And so what I realized is that this is how I think Neo is going to be relevant to a lot of these containerized applications. You'll be able to pull it in and then integrate all the data that's in all of these different microservices into one place where it can become one unified view. And all the plumbing will be made easier. The hard part will be the graph ETL, bringing it all in. But then once you have it in there, you'll be able to look at this kind of formerly distributed set of information that was trapped inside all these microservices. You'll be able to look at it in one unified way, which I think is, obviously over and over again, the power of graph. I think one of the biggest frontiers that graph is making a big impact in is in delivering what we always wanted from the data warehouse and then subsequently from the data lake. In those realms, what did we want? We wanted in the data warehouse integration of data from all of these applications. And then that data warehouse has succeeded brilliantly in creating a canonical model that was basically a language that you could use to describe your business. Now the canonical model didn't evolve quickly, and there were a lot of problems at times, with the brittleness of the system, and sometimes, the brittleness of the things you had to do to make it perform quickly. But once you had that canonical model, it radiated value. Now the data lake just said, wait, what about all the rest of the data? And so the data lakes were much better at storing that data than they were at integrating it. And so I think now, especially with knowledge graphs, we can take all the information that was in a data warehouse, all the information that you collected in a data lake, and all the information in place in all the other applications, and we can bring them together into a unified graph and keep up to date with it. Again, one of the big problems is the ETL aspect, but once you do that, you're in much better shape. And I'm really excited about the role of semantic standards, applying a knowledge graph with semantic standards so that you can ETL not just into the nodes and properties, you can ETL into semantic standards and then have the graph automatically created. I think that it's really interesting what's happening with Neo4j because one of the aspects of the company that's very ambitious is that you're trying to not only be a OLTP transactional operational database, where you can actually power applications as a system of record. You're also trying to build the plumbing to be a analytics, OLAP, database where you're going to be a first-class player as an analytics player. It's not happened in the relational world. We have different categories of databases. Teradata for OLAP, Oracle or Sybase and things, for the OLTP. Neo is actually saying, no, we are going to be committed. We are not going to be one or the other. We are going to be both. And I think that's really ambitious. And I think obviously, if you pull it off, then it really makes a powerful result because you don't have to do the moving of the data from one of those databases to the other. So it'll be I'm really eager to see someone who actually comes back and says, yes, we're super operational with Neo and we're also super analytic.